again, put your hands together for Rick and thank him for putting on the meetup tonight. It really is a great thing that he's done. I'd also like to point out that both Phil and I are on Team Sticker Free, so we are those people, and we have taken over your meetup tonight.
I have stickers if you want.
Fairfax Media is one of Australia's largest publishers. They've got mastheads, as you probably know, across Australia, including in the 3 largest cities, Sydney, Melbourne and Brisbane. And by late August last year, the team I'm on at a company called HumanMade had been working with Fairfax for around about 10 months. And that's why I found myself at home on a Sunday night with a glass of wine in hand, a quite nice glass of wine in fact, watching as they relaunched their Brisbane masthead, the Brisbane Times. And at 8:08 p.m, the site relaunched. Now, neither I nor anyone at work at HumanMade had anything to do with the rendering of the page. But it signalled that in the newsroom of Fairfax Media's Brisbane Times, they'd started using a new CMS. They'd started using WordPress as an enterprise-grade CMS, and that's what I want to talk about today. They're using it in their newsroom and replacing a proprietary CMS with one based on open source. It's something the team I'm on at HumanMade and the team at Fairfax have been collaborating on since October 2016. Additionally, our friends at a company called XWP contributed a feature over the course of a month or 2. The feedback that came back was that it was just another day in the newsroom, which is what we, and when I say we in this talk, I mean Fairfax, HumanMade and the other suppliers, were wanting to allow our users to get on with what they do best, writing content, and for it to be delivered successfully to their readers. Today's talk's sort of the technical presentation of a white paper that HumanMade will be releasing on the project. While the white paper will take sort of wide view of the features, I'll be looking at some of the code that went behind those features tonight. And I'm well aware, that WordPress's reputation could be better in certain circles. Probably I'm standing right in the middle of one right now. But so today I'll be attempting to show some of the ways that enterprise WordPress ain't what WordPress is typically known as. But let's start earlier. Fairfax's internal team wanted to reimagine their tech stack. As a digital publisher with over 20 years experience, a lot had changed since they first went online back in the 1990s. In very, very, very simplified terms, the new stack looks like this: WordPress at one end and the website at the other. In the middle, there are databases for the content and for the media, and they're all connected by the content and media APIs. Additionally, images are served by a third-party provider, so the provider and the provider's APIs are also in the mix. But it's very important I say this, most of the stack was built by WordPress. And for the most part, all the CMS team that I was on had to worry about were the 3 APIs that came out of it: the Media API, the Content API, and Cloudinaries API. There are several main features that we built that I'll be covering today. I'll be covering replacing the WordPress publishing and workflow features. We removed WordPress's default publish box and we replaced it with what we called the publish box of the future. With both Fairfax's Media API and Cloudinary API in the mix, the built-in media library needed a bit of a facelift. This includes making different custom crops available each time an image is stored in the article, is used in an article. And once you're dealing with thousands of tags, a lot of care needs to be taken when it comes time to importing those into the WordPress. How they are accessed from the database also needs to be carefully considered. And this is something that we learned with perhaps more bruises than we would have liked. Before I came down today, I checked out how many tags work users on their blog: 90. My personal site is, perhaps unsurprisingly, less disciplined, with 118. While checking these counts, I also ran this query on my local dev server for Fairfax. And the number that came back is still a little bit startling. Oh. Yep, a little over 23,000 tags. And these are published on the Fairfax Content API and we import them periodically using a cron job. It seems like a lot. It is a lot. But there's a lot of places in the world, and that's before you start thinking about people of note. Fortunately for us, WordPress has some built-in functions for the scheduling and running of cron jobs that we can use to import our tags. For each of these jobs, we get 50 tags from the Content API and add them to the WordPress database, and repeat this several times until we have 23,000 tags. But I'm getting ahead of myself. We got a little bruised because when it comes time to import the tags to the database, well, managing tags makes a lot of complex database queries. But this isn't what bruised us. We knew this going in, and at large scale, you need to start thinking about the database queries. It's simplified, but this is the code that we need to run each time we insert or update a tag. We insert the tag itself and then set some associated metadata. But before continuing to the code that bruised us, let's run through what happens to the database when you run this code. First, WordPress will check if the tag exists via a slug. On the initial import, it doesn't, so WordPress will see if the tag exists via name. Strap in. This is followed by checking the tag's name against the parent again, checking the slug is unique, actually inserting the tag. Let's celebrate briefly. Checking if the relationship data exists already, parent, taxonomy, that kind of thing. When inserting a tag, it doesn't, so let's keep going. Actually inserting the relationship data. And finally, a logic check to ensure that a duplicate hasn't been created. And that's just to insert the tags. We have 2 types of metadata to insert, so we need to run 3 more queries, twice. And for hierarchical taxonomies, the hierarchy is calculated. WordPress updates what grows to become a very large option every time a tag is inserted. But we knew this. We knew how heavy on the database inserting tags was going to be, and we were prepared for it. WordPress was to be Roxy Hart to our Billy Flynn, and we were going to make it our puppet. We were going to control for these slow queries by slowing down the import significantly. Just do 50 tags every 10 minutes. The initial import would take some time, a couple of days, but the database would survive, or the site would survive. And we'd see how it went using a small number of tags, just a few thousand locally, and then decided if we needed something complex to allow for the scaling of cron. However, one morning we woke to discover the world. Or more to the point, the 14,919 points on the globe that had been added to the Fairfax Tags API and that WordPress was importing in turn, which essentially turned all of our environments into this, but slower. Fortunately, however, this was 3 months before the launch, so it didn't affect our goal of just another day in the newsroom. What happened was that we needed to immediately rewrite our code and then tidy it up for a second time. And even as I was writing these slides, looking over the code, I was thinking there's probably still room where we could tidy things up a bit more. You see, using WordPress's built-in cron doesn't actually use real cron. When a user hits a site, in our case a reporter, let's call her Mary Sunshine, WordPress makes an asynchronous loopback HTTP request to fake a cron job. This in turn made an HTTP request to the Fairfax Tags API. We'd set up a cron job to process the import later and then get the next page of tags from the API. And this worked at first when there were a few pages of tags. But once we hit a lot of pages, by which I mean 320 pages, the call to WP cron, as it's known, would time out after 30 seconds. And that's what we forgot. It had slipped our mind that a loopback HTTP request is still an HTTP request. It would still time out after 30 seconds. But in that 30 seconds, some things had happened. We'd already started storing the cron jobs in the database, which is stored as a single option. My boss was once said on stage that WordPress is a piece of shit. I would not, of course, agree with this. When the job failed, the same job would run again and add the same data to the database. But meanwhile, it had already started setting up the import jobs, so the cron job would also start inserting the tags. We reverted the original commit and determined that we did indeed need to allow for the scaling of cron. And for this, we used an existing human-made product called Cavalcade. Cavalcade is a runner. Yep, it's a pun. The nice thing about Cavalcade, though, is that these two lines, it filters some WordPress functions so that it becomes invisible to me as a developer. Developers continue using the same functions, but without the risk of bringing down the server again. Although using a proper job runner does allow us to change how we use these functions. In production, the code we ended up running didn't look too different to the original code. If anything, it looked a little bit less considered. Instead of throttling the imports, we scheduled them to all happen immediately, all 320 pages. Well, okay, by the time we deployed this code, all 460 pages. Instead of getting the tags while scheduling the cron jobs, which was, in retrospect, a mistake to deploy, we started storing the arguments needed to make that request. But this wasn't for the most obvious of reasons. By moving this to the task, we could run multiple HTTP requests in parallel. And remember, we've just scheduled 460 of these suckers to happen right now. We weren't completely cavalier, though. We also introduced some locks to make sure that we could prevent the double scheduling of imports. And the Cavalcade runner actually runs as a process, which is really handy because crontab has a limited granularity of 60 seconds. We're not limited by that by having a process. In the first iteration, we were slowing down how often these jobs could run. In the current iteration, they can't run often enough. Our new import runs much as before, but because we're running as a server process instead of as a loopback HTTP request, we don't have to deal with 30-second timeouts. The process runs as long as it needs to run. These tasks also run on a server dedicated to the process, which means that they're not going to be ever affecting users of the web server. We're now running 4 jobs in parallel and running the next as soon as the previous job finishes. We were throttling the original import to take over 53 hours. The new code allows us to complete it in around about 30 minutes. When I was going through the database queries earlier, I kind of skipped over the biggest, or at least didn't give it its due attention, and it's the final query on this page. Updating and recalculating the term hierarchy option, which is a caching mechanism, which in our case, at 23,000 tags, blows out to 335 kilobytes. It's rather large. And it tries to, and this tries to get updated every time we insert a tag. So to avoid this, we address one of the most difficult problems in computer science, cache invalidation. Or more to the point, we completely ignored it by never adding to the cache when we were inserting those tags in the first place. We suspend updating the cache on the threads doing the imports, which also means that we don't have to worry about the 4 parallel threads, each reading an old cache while a new cache is being written. It's also quite nice to find that a fairly niche purpose function like this exists already in WordPress core for allowing us to import large amounts of data. Enterprise WordPress isn't your typical WordPress. While bringing down the server importing tags was certainly a low point, undoubtedly, we actually managed to get away without too many wholesale reverts, which is kind of pleasing considering the project has been running now for 16 months. One of the earlier features we worked on was to enhance the WordPress media library. And this is the default version from my own site. The Fairfax library has far fewer photos from my New York holiday to see musicals. And in the default media library, to upload an image, I simply drag it into the window and drop it. And once the image is uploaded, it's added to the library, of course. It's not an uncommon interaction by any means, but it's a really nice one all the same. And it's one that Fairfax wanted to keep when they moved to WordPress. What they didn't want to keep were some of the limitations of the WordPress library. Images are not served from a CDN. Each image is limited to 4 fixed crops, thumbnail, small, medium and large. Image crops are defined globally. Both images and articles are stored in the same database table. File names are not systematic. And did I mention that images are not served by a CDN? For a typical blog or a small media site, these aren't show-stopping problems. In many ways, the simpler is better. These limitations are a feature. However, introducing these limitations to Fairfax fails the just another day in the newsroom test. So switching over to the Fairfax media library, it looks much the same, deliberately. The users don't care. And it behaves much the same. And this is my local version. The real thing has many thousand more photos, and they're not all from the musical Dear Evan Hansen. But apart from that, this is the Fairfax library. And a lot more happening in the background. So let's start early in the journey. A journo wants to upload an image to the media library. In this case, they're uploading a duplicate image. The first thing we do is rename the image to a hash of its own contents. Among other things, this allows us to check for duplicates and discard them instead of including multiple versions of the same image in the library. It also provides this nice systematic file names that we were missing earlier. And it's then that the interesting stuff begins to happen. From the diagram earlier, instead of storing the images in WordPress, we hit the Fairfax built media API, and their media team deals with serving images to the site. The moment a journalist releases their mouse on the screen, we take over from WordPress. At this point, when they release their mouse, the browser is making a post request to upload the file. Now, WordPress really wants to run its own code at this point, and there's no convenient or proper hooks that we can use to take over the function that we're targeting. So we have to take over the entire process right from when it initializes. But we pretty much follow the same process WordPress follows and duplicate a lot of the core functionality. But instead of stopping once we've uploaded the attachment, we in turn upload it to the Fairfax Media API. And perhaps unsurprisingly, this is done by hitting their API with JSON formatted meta and file data. More surprisingly, the image is actually sent to the Fairfax API as a base 64 encoded string. And I've noticed that this is sometimes larger, it's sometimes smaller than in the original file because computer science is weird. Once we convert the image to the required schema, the data is stored on the Fairfax Media API. And this solves a problem I identified earlier of data and content being stored together. But at this stage, the file has still been added to the WordPress media library. We rectify this problem by deleting the image from WordPress immediately. It's no longer needed. So that's how uploads work. But now that we've handled them, let's take a look at what happens when a journo wants to insert an image into their article. In particular, what happens when they first open the media library. Standard WordPress makes an AJAX request to query the attachments, and an array of data is returned with the information about the attachments as stored in the database. But as you saw, when we uploaded the image, we don't have anything in the database. However, the WordPress default format is actually really quite nice. IDs, metadata, and sizing information about the image. It's also nothing like the data that the Fairfax API returns, because one of the nice things about systematic URLs is that they're systematic. So the Fairfax API returns only the most basic of information. And replacing the entire media library to refer to a third-party API seems like a fairly heavy touch. And it is, trust me, I know this. But in doing this, we wanted to keep our touch on the code as light as possible. So it turns out that to get a WordPress formatted response, there are only two functions that we needed to replace for handling the AJAX request. The first to query multiple attachments, and the second for querying a single attachment. In a roundabout fashion, both of these functions wrap a function to convert a Fairfax JSON response for an image into one WordPress is expecting. WordPress expects the response to include various sizes, but the Cloudinary URLs are dynamically generated. The full-size image only uses the image ID, in our case, the hash of the content. The thumbnail makes use of what's called a named transform. You can specify the width and height to get a best guess crop, or you can specify completely custom crops. But for the default crops used in WordPress to preview things, we define the images as you usually would in WordPress, which is just using these add image size functions. And by doing this, it allows us to use these image sizes throughout the entire CMS. Each of these lines, however, causes an image of those specified dimensions to be created on upload because WordPress wants its fixed crops. And we delete these images as soon as we upload them. So creating these crops can only be described a waste of time and computing resources. Fortunately, we can disable the generation of the custom crops with one line of code. But that's only half the story. The CMS still needs to know the URLs for our intermediate sizes. Surely WordPress, which lets you filter everything, has a convenient filter to allow you to do this, right? Wrong. Everything in WordPress is filterable. That's what makes it so easy to use and easy to abuse. What we discovered is that when you're getting an attachment, WordPress essentially verifies the ID as the first step by checking it's an integer, which in our case is an alphanumeric hash of the content and very much not an integer. And in no way is this filterable. At this time we were writing this, I really would have liked to have been filterable. It also came mere days after I'd had a big, long discussion with another developer as to why I thought it would be problematic to allow the filtering of ID validation. I still think this is true, by the way, but it didn't make it any easier knowing it at the time I was writing this library. So our solution does not feel entirely elegant. We wrote a bunch of functions with comments along the lines of, this matches the signature of the core function, but modified for the API. We wrote them to, as often as possible, match the core signatures to be kind to the developers that came after us, or even our future selves. I, and a lot of other WordPress developer types, know that core returns attachment metadata as an array of the original image and then the resized image's dimensions. For our modified version, we added the URL because it's external and doesn't follow the rules that WordPress is expecting. But by substituting the response to these AJAX functions to build from our functions and matching the core signatures, we could convert the Fairfax media API to the format expected by the media library in WordPress, or at least a representation that we could largely deal with. As far as the client-side code is concerned, though, there's a few problems. The ID is still a string and not an integer. There's something in there called a URL, and the size names have been customised. If we look back, though, at the default media library, the one from my site full of holiday snaps, the client-side code is made up of dozens of views and subviews. The default library has its main content, the individual attachments, the attachments details, form elements, inputs, buttons, that kind of thing. There are over 42 exposed views in total. And all these views, along with 6 models and 19 collections, come from inheriting the client-side tech in WordPress, including the libraries that WordPress uses for the media library, which means underscore, backbone and jQuery. But by doing the work on the server side to emulate the output the CMS and the client-side code was expecting, we managed to get away with making minimal changes on the client-side code. We had to override the model, a single attachment, a collection of multiple attachments, 6 views, and many of these would just customise the display, and we also had to override how the data was queried itself. And this last one sounds like a big one, overriding how the data was queried. In reality, it was to ensure that we used our own custom models and to ensure that items were ordered as expected, from newest to oldest. If a journalist is searching for the Tony Awards, they're much more likely to want an image from the 2016 Tony Awards than they are from the 2017 Tony Awards than they are from the 2016 or 2015 Tony Awards. They want a recent photo. Some of the views were overwritten to change the template used for display, and the original purpose. And for example, the original purpose to change this template was to use the URL that we'd define in our customised JSON schema. By going heavy replacing the default values on the server side, it allowed us to make the changes on the client side a relatively light touch. We made changes to about half a dozen functions at most on the server to avoid making complex changes to over 42 views, 6 models and 19 collections. Or more to the point, it allowed us to focus our efforts on client side to changes for the more difficult elements, such as when it came time to replace the default insert selection with something much more useful for actually inserting an image into an article. which does require that we start creating our own custom models and collections and completely custom views in which to manage them. But we use these views and models to change the URL of the image that we are inserting to allow journos to completely customise the crop. Fortunately, we didn't need to worry about saving these changes as they're modified on a per article basis, because that was the specified goal. To stop making image crops global, and the generated URLs are inserted into the article and saved with the content to be displayed. The custom crop becomes part of the content. One of the biggest changes we made to bump the CMS into something we could consider enterprise ready was to improve upon the WordPress default publishing and workflow features. Among other things, we took the default WordPress publish box and replaced it with what we modestly called the publish box of the future, which, while lacking in hubris, started as a convenient name while we were building the UI. It had allowed us to distinguish between the one that worked and the one that would work in the future. If you ever find yourself in a position where you need to make anything more than minor changes to the WordPress publish box, may I suggest this approach? Kill it. Just kill it dead. It will just get in the way, I promise you. We replaced it with our own meta box and built it out in JavaScript. We also renamed it Save and Publish because while there were two publish boxes on the screen, it was convenient to be able to tell the two apart. One of the goals was to avoid full page refreshes, which means saving and publishing via the WordPress REST API. This involves customising the default post endpoint. Post is what WordPress calls an article. Customising the default endpoint to add our custom metadata to it. Each of the custom properties are namespace to ensure that we don't end up clashing with the default property that may be added in the future. We need to add a custom property for each item of metadata that we've added to the edit screen. In our case, this is rather a lot. In fact, it's such a lot that we needed to split the screen into two tabs, one primarily for editors, setting the editorial requirements for an article, and the second primarily for the reporter writing the article. We ended up adding over 61 custom properties because it can take a bit of work to keep it just another day in the newsroom. For each of these properties, we're adding them to the endpoint, and we needed to include information about the schema. For example, whether it's a string, an integer, an array, or whatever it may be. By registering the property and including the schema, it allowed us to get the required models and collections extended to include our properties for free. To do so, we needed to extend the libraries we inherited from WordPress to include the WordPress REST API's backbone library. Yay, more backbone. It's complex, but by correctly defining the schema and including it in the client including the client library, we instantly have access to our properties on the post model. And the automatically generated model is aware of the validation rules. This gives us a head start for client-side validation, while full validation is automatically taking place on the server. So I've just spent a good chunk of time talking about the code that we wrote on the project. On the human-made side, this is who we are. We built the project with the core CMS team at Fairfax: Ben, Arpita, Luca, Chris, Tim, and Udit. And as I mentioned, our friends at XWP contributed a feature. When I talk about us and we, that encompasses a lot of people. In total, there are 31 people who have non-merge commits on the project. And about 2/3 of those at some point or another worked 40 hours a week doing dedicated work just on the CMS. Between us, we made around 11,500 commits and counting. Once the last person at Human Made wraps up, the internal Fairfax team will continue building the system. This number's just going to grow. For most of these commits and pull requests, my job was code review. It got to the point that introducing myself on more than one occasion, I made this joke, that my job is code review and fooling myself that I really will get to pick up a ticket today. As the team grew, I'd spend 40 hours a week reviewing code. I didn't write any of this code, the team did. And when you take merge commits into account, words. When you take merge commits into account, about 3% of total commits are just me clicking the merge button on a pull request after it's been approved. It's very easy to think of code review as unproductive time. One of the biggest lessons I learned building this project was that code review is productivity. And that's my guilty secret. I enjoy code review. But I also think code review is a good part of what makes a project enterprise grade rather than anything else. To put it better, as the team and the time grows, spending extra time on code review no longer is an affordance that's no longer considered a luxury, but becomes part of the process to build a stable product. So when last Sunday the Age switched to the new stack, signalling that the Melbourne newsroom was primarily using WordPress as their CMS, the fact that it was safe to do so had nothing to do with the code base per se, but everything to do with the processes around building that code base. And that's what made what we did an enterprise CMS. Thank you.